So we're going to talk a little bit about procedures now for lab reports. So the first thing to think about is why do we even bother writing a procedure? So on the most basic level, a procedure just tells the reader what was done in the lab so they can better understand the lab. Going a little bit deeper, it gives enough information so that the experiment could be repeated. A lot of times, experiments are repeated in a lot of different circumstances and a lot of different situations to help verify the results. So you want to have enough information in there that someone else could recreate your experiment. All right. And the other thing too is the procedure really helps to give credibility to your results. If you don't have a good procedure, if you didn't follow the proper steps to do your lab, it really doesn't matter what your results are. They're really not valid. So the procedure is where you justify that, hey, these results are valid because we did all the things we should have done to be able to prove this or to answer whatever question we're trying to answer. So what your procedure should look like, and this is really, really, really important, okay, because it's different than probably what you did in chemistry, okay? Your procedure in this class is not going to be a step-by-step, okay? The procedure is going to be a paragraph that describes what you did in the lab, okay? So it's really a narrative, it's a past tense thing saying this is what was done in the lab. You're not saying what could be done. You're not saying what should be done. You're not giving the steps or writing it in command form. Okay, it is really telling what you actually did in the lab. So it's a description of what you did and how you did it. Okay, and there's really a few things that you want to make sure you've accomplished by the end of this. Okay, you want to have the reader understand what you tested. Okay, so what were your variables, why you tested those things. So you might want to justify how those variables helped you answer the question, and how exactly you tested it. So those are really the three things, and we'll go into specifics on the next slide. Okay, so let's get into the actual part of the procedure. So the first thing you're going to do is you're going to provide an introduction. And what I would do is I would simply restate the purpose. I realize that you've probably already said that in the previous section. It's okay to be redundant. It's okay to state the purpose again. It's really a nice launching point for going through your procedure. The next thing that I would do, and there are a few possible orders that you could do this in. This isn't necessarily the one correct order, but I think the one that makes the most sense next is to identify the variables. Talk about what was the thing that you actually tested, the thing you controlled for. Be a little bit careful, all right? Just because you measured something does not necessarily make it a variable. What I'm really talking about is independent variables. And if you haven't taken stat, here's the key difference between independent variables and dependent variables. Independent variables are things that you actually changed, okay? Things that you had control over. Dependent variables are things that might have changed as a result of what you changed, but weren't necessarily something that you had direct control over. So, in the pullback car lab, think about the variables that you had. What did you actually control? You controlled how far you pulled back the car. That was the only thing that you had control over. That in turn affected how far the car went, but you didn't actually have control over directly how far the car went. All right. So we're going to state what the independent variables were, what we had control over, and we can state what we measured as well, what the dependent variable was. But it's important to make sure we state what the independent variable is. Next, we're going to describe the lab, right? That's really the bulk of the procedure, okay? State what you did, okay? What did you do to complete a test, okay? How many measurements or what measurements were made and how were they made? In other words, what equipment did you use? If you did multiple trials, how many trials did you complete? That's a good question to answer. What was the range of values? So maybe you say something like you pulled the car back 7 different distances between 5 centimeters and 20 centimeters or something along those lines. Okay, giving the range of values. You don't want to list every single value. That's really not necessary. But giving a range is a nice, concise way of giving the reader some idea of what values you tested. Once you describe what you did, up next you want to describe how those measurements allowed you to complete a test. Now, this one actually isn't as relevant in the pullback car lab, but there will be some labs where we're not going to directly measure the thing that we really care about. Okay, for example, we might measure the velocity of an object and use that to calculate its acceleration or something along those lines. So, if that was the case, okay, if you didn't directly measure the thing that you care about, you need to talk about how you actually got that value, okay, how you took that velocity and calculated the acceleration. So you would probably include the specific equation that you used, if you had one. In the Pullback Car Lab, there really wasn't anything because we directly measured everything. But if we hadn't, then that would be an important thing to talk about. All right, and the last thing I would include is just a brief statement about error reduction. What were some of the things you did to increase the accuracy of your results? Okay, there's a few things that we can do, and we'll talk about this a little bit more in class, but think about, what were some things, not necessarily the sources of error, that's something we'll save for the end, but what were some things that you did as you were doing these measurements that are going to help prevent error? Obviously, you're not going to eliminate it, but you can help reduce it and prevent it to some extent. Things not to do in the procedure, okay? I cannot emphasize this one enough. Do not write it as a how-to or an instruction manual. So it should not read, get the mass of the car, pull back the car a set distance, all right? There should be no commands in this. It should be talking about what you did. So rather than saying things like pull back the car, release the car, and measure how far it went, okay, you're going to say what you already did in the past tense in the lab. The car was pulled back and released. The distance the car traveled was measured. Okay, that's really key. And along with this one, all right, and this is just a general tip, but we'll talk. We talked about this before. No personal pronouns. Okay, no I, you, we, any of that. All right, it might feel a little awkward at first because you're not used to that style of writing, but we shouldn't have personal pronouns in the procedure. All right, and then the last thing is do not include any results. All right, we have a section for that. Don't jump ahead to that section. Your procedure section is simply for talking about what was done and justifying your method, not for discussing the results of the lab. All right, so here we have a sample one. I'm not going to read through the whole thing, but I do want to point out a few things, just point out some of the things that we talked about here. So first we have the goal of this lab was to examine, and this is a different lab, but to examine how the length of a pendulum affects the period of oscillation. So right there, we have a restatement of the purpose of the lab. Okay, that was the first thing we talked about. The only variable examined was the length. So there we are identifying the variable, the independent variable that we had control over. All right. This next bit here then goes into the actual nuts and bolts of the lab. Okay, so what the setup was like. A simple pendulum was created and we hung a mass from it. All right. In more complicated labs, we will draw an apparatus drawing. In this lab, we didn't need to in the spring or in the Pullback Car Lab simply because it was pretty basic. There wasn't a lot of complicated equipment. But in future labs, we will do a drawing. So this is describing the setup, okay, of the lab. Then we start here for each trial, okay, that was tested for each length. This is specifically what we did. The pendulum was pulled back and released, causing it to oscillate. All right. The time for 5 oscillations was measured. So this is what was measured once we did that trial. Okay. And then we're talking about how many trials we took. So 8 different pendulum lengths, the range that was tested, and how many trials were done of each. So that's that last little bit of talking about how many trials you did. All right. So now we've kind of wrapped up what was done in the lab, and now we're going to talk a little bit about how we analyze the results. So we graphed and did percent difference calculations, and then how error was reduced. So error is reduced by ensuring that all the variables were held constant. Okay, that's a big one. That's important that we hold the other variables constant. And then the other thing, and this is actually really easy, and you did this, was conducting multiple trials and averaging results. That helps to reduce error. That's something that is going to help. Notice, by the way, that this is not stating the sources of error. This is talking about 2 things that were done to help reduce that error. We'll get to the sources of error in the conclusion. So that's your basic procedure. You really want to make sure you're hitting on all those points. The biggest things that I see are writing it as a how-to, okay, and not really giving a good description of what was actually done. Those seem to be the two biggest downfalls in the procedure. All right, we'll be working on this throughout the year, so they will get better if you're willing to put in the time to work on your lab reports.